I'm here to present a little bit of our experience in storage in Latin America. Okay, I'm Genaro Acosta. I have a Ph.D. in parallel computing. I'm from Eviden. It's the company that has a booth over there. Eviden, just a bit of a history. Eviden is a company, a spin-off of Atos. Atos has bought Boo, and Boo is manufactured for high-performance computing for a very long time. We start developing computing in France. It's a French company. We work on mainframes, and we have integration. We build processors, we build high-speed network, and we do all the things that till now to AI, like the integration that we have in NVIDIA and everything. So we are partners for DDN for a very long time, and most of the system we deliver uses DDN as its backend. Well, we are the biggest HPC provider in Europe. We had the #1 HPC provider also in Latin America and India, but we also provide HPC for the industrial customers. Okay. Here I want to present, this is something that we had in Brazil. This was the machines that we have in the top 500 right now. We won the most deals on the oil and gas in Brazil from Petrobras. And also the Research Institute. We have here Santos Dumont, that one that will detail later, and also Senai Cimatec, that one the north of Brazil. Something I want to like to say to you is that those machines are GPU machines. And those machines are this one on black. The ones machines that were built on NVIDIA GPUs, but are based in air-cooled technology. The ones that we provide in Santos Dumont, one is the DLC. And I like to highlight this because we have several problems on lifespan for air-cooled GPUs, because the air-cooled GPUs, if you don't control exactly the temperature, you have issues and you have a higher failure rate. Okay, we're not doing only HPC. We are bringing HPC to AI. That is the case that is close to AI to HPC. We implemented a cluster of about 40 DGX in Ecuador, and this cluster is doing computer vision for more than 18,000 cameras. Okay, so we received this stream of video. It's about 3.5 gigabytes per second of video stream. We analyze all these video. We detect objects. We understand what the objects are doing, the scene, like velocity and everything else, and then we save this and then store it and has a data lake for the security to work on it. This system is based on a Lustre. They have 31 petabytes of Lustre and a system from DDN of 21 petabyte based on S400 and X62. The interesting is that why DDN on the system? Okay, because we can fail fast and recover fast for these fails. Okay, it's very interesting. It's running. It's real time. It can't stop, and something we deliver and we maintain. We expecting to double the number of cameras soon. I will not say about only success, but I will tell about bad behavior in storage. Okay, this is one for a seismic moment in Brazil. They has a problem that they need to sort a big file. Okay, and they are using the storage to store very small piece of data. Okay, it was 7K. It's not aligned, and this is what a problem, because when we deliver that over Lustre, with right operations, we have a lot of data come from the servers to the client. Okay, that's because it's hard to tune a system to have all the applications. Okay, so we have the unexpected behavior. You have to change the system just to match exactly the need for the customer. Okay, so of course they could change the application, but we need to tune the system specifically for that. Another bad that use for storage that I have, it was one for the seismic image. This is an image for the ground. Is that said you get a ultrasound for the soil. Okay, in the process that you get the data, the sample data that they do on the field, and then they have to map below the ground. Okay, these shots reads and write 900 gigabytes, and this is stressed the system they have there. We had better experience for that, and the solution as an architect was to use local cache for this data. You know? Well, I'd like to highlight a paper that was come around from about three months ago. It's a paper that explained all the training for Meta. It's very interesting because we have now a model that is about 800 gigabytes for model. Okay, they had a cluster of 25,000 GPUs. They only use 16. Okay, the storage is a huge one. It's 240 petabytes. It's spread about 750 servers. But the interesting here is that about this cluster with this kind of characteristics, they have to do a lot of checkpointing. But why they do checkpointing? This is all the fails that they have in the 54 days of training. Okay, so in 45 days of training, they have 419 failures. If you think that, it's about one fail every 3 hours. So as machine scale, this is a quarter of the machine that the LMX buy for XAI. Okay, so if you double the machine or quadruple the machine, the number of fails get frequently. So checkpoint right now is not a need. Checkpoint is a necessity, is mandatory for execution. Because once you are running all the machine, your machine will fail in the next hour. So you have to check the work to get back. You know that there's a lot of failures, not only for GPUs, okay? You have failure for the interconnect between the GPUs and CCL, for example. Sometimes it's failure for the power supply. Sometimes it's software bug, okay? But the point is that all the system has a good variability when you have few companies, but when you add more companies, the system will fail soon. Well, we are doing DLC for a very long time, okay? And this is interesting because if you have a system that can handle heat, you have less stress over the companies, and with less stress, you can have less failures on those elements. Okay, we're building the first exascaler. This is based on our technology. The first hack is the #1 Green 500. It is most efficient hack system ranked, and we have a second model. It's a container that's 13 hacks. It's in the position 6 of the Green 500. Okay, so we can do scale with efficiencies. Well, in delivery in Brazil, we are delivering right now about 5 hacks using this kind of technology. Is this picture you have here? If you want to see the blades are displayed on our booth, and all those problems that we had before, we expect to be solved with those storage that they're provided by DDN. One focus on IOPS and bandwidth, and another to focus on space. Okay, this machine is installed exactly right now. Okay, so at the end of the year, you have the available for the community. This research center in Brazil serves more than 700 researchers all over the country. It's the biggest research center that we have in Brazil. So I want just to state here is that with big workloads like LLMs, we need big systems. Okay, big systems we sure have components fail. If your components fail, all your work will fail. So to reduce the fail rate, you have to have a very good design, not only network but also storage compatible to the number of GPUs that you have. To tolerate these fails, the technical that we have today is checkpointing. Okay, there's a lot of things about that. NVIDIA is doing a great job to provide some hardware, for example, to do compression checkpoint, but you should save your work very frequently to have to be safe in this kind of way. And not only the storage, you have to have a network, and now all the system design to handle those kinds of fails. So it's tricky. That's the message. Thank you very much for hearing me. Okay.